Thank you very much for inviting Kasia and myself along. It's a pleasure to come and speak to you. I am
Sorry, David. I think I can't hear you. Is it just my problem, or is anyone hearing?
I can hear David. Can you hear me?
I think it's my problem. Yeah.
Yeah, I can hear as well.
Great. Thanks, guys. Yes, continuing. Yeah, we've both Kasia and I have given this talk, as Lou said, last year, and this is a reprise, as it were. And I've been working in geosynthetics for 40 years, and just as a matter of interest, I came from first of all the construction industry. I had a short time in teaching where I taught science. And so in 1983, I moved from a laboratory in a classroom to a laboratory to a large manufacturer doing a testometric test. And what was most intriguing last year, on the day that we gave the original talk, Kasia was born 40 years prior to that. Kasia's got my permission to show, and she provided this, and I can't help saying she looks very cute. So that was a rather nice. The point of that is that we thought it was rather good for me to share what I've seen in the 40 years I've been in this business, and the development, especially with regards to the awareness of the environmental world, and then to hand over to Kasia so she can see what's going on now and how she sees things going on into the future. Of course, the thing that we were celebrating is the 40th anniversary of the setting up of the IGS. And I'd recommend you looking at the handbook, which was specially produced for that. If you haven't already seen it, you can get that on the IGS website. Just to get some definitions at the beginning of what we're talking about, this was one of the seminars in a series of seminars, and it focused, of course, on the environment. And this is just to get some definitions and what it is we're talking about. So bear with me for all those who are well versed, but this is to catch us up to the same place. So what we're doing is we're looking at measuring the cost that our construction efforts make on the Earth. And one of the key measurements, of course, is the measurement of carbon. There are other measurements, but the one I wanted to focus on today was the measurement of carbon. And looking at there are various things that are easy to measure and others less. And as you can see, what I'm going to be reporting on and looking at is the embodied carbon, which comes from the actual production of a product that's used, and also some of the operational carbon, which is used for constructing. So we'll be looking at the total life cycle of a product. We'll be looking from cradle to end of construction. Now, there's some excellent work going on in the IGS and amongst members on looking at recovery. There's usually very little maintenance with regards to geosynthetics, but it's the recovery side. And in many cases, that's very low carbon, because just taking the material out of the earth. But some are just exhuming grids and so on, just to see what sort of costs that involve. But it is proving to be a relatively small percentage. Now, what are the drivers for us doing this? And we grandly called this 40 years saving the Earth. Well, we literally are doing that. And this is a great example, especially relating to Australia, and the Burj Khalifa, which has used 110,000 metric tons of concrete. Well, the specification for the concrete required a particular sand, an aggregate, which could only be found in Australia. So all the sand for that project from a place that's next to the desert had to be imported from the middle of Australia. So you start to get an idea of what might be the carbon cost of that. So in terms of the materials that not only sand and gravels, these are the the materials which we're talking about, which are relevant to what geosynthetics can save. So what earth are we saving? So we're looking at quarried stone. It has to be graded and crushed. Often single-sized drainage aggregate required, or a dredged river aggregate, often specified to be rounded for various applications. Sand has to be angular, for it's specific for concrete production, for it to work correctly, often using bedding layers and filter layers. Quarried clay, obviously that for where a lot of work is done on the use of suitable clay for landfill lining, and that has to have very specific requirements of low permeability. It's to be a clean clay to achieve low permeabilities. Concrete, as we mentioned, is very specific on to get required strength. You have to have the right components as aggregate and sand, etc., and used obviously in structural concrete, but also in components and blinding concrete. And then asphalt, which obviously uses stones and grit stones. The next concern, of course, is to get this material out of the earth. An excavation can require blasting and sorting and transporting. There's environmental impacts such as noise and dust. And then there's restoration to consider right at the end of a contract under planning rules, and the costs involved in improving and restoring the aesthetics of the area. And there's often impacts on water tables and any drainage that's needed for that. Then we have to transport the material. It's all very well blowing up a big quarry, but they often are large distances away from the actual construction site. And to achieve moving these heavy, bulky materials, of course, you are having to use heavy machinery, which often don't fit in the areas that we might want to get to. Now, I know you've got some big open spaces in Australia, but here's an illustration in the UK with a little village where the only access through to a site was through a back street in a village. So there is all sorts of hidden environmental impacts when trying to get these heavy materials through to the site. And also, finally, and not least, is the damage it does to the road surfaces. One of the biggest complaints to the local public offices is the amount of potholes. I don't know whether that's true in Australia as well, and New Zealand, but it's the biggest complaint that our politicians have to put up with. Then you have to construct the material, and that means often a pre-excavation of the site to get a formation, movement around the site, and placement, of course, preparation of soils, compaction, etc., and finishing, which all add up the carbon requirement. Of course, the applications, which I'm sure you know very well by now from the excellent work that ASIGs have been doing, but just as a reminder, where these materials can be used in railways and bridge construction, road construction, and wall and slopes in any applications, and of course coastal protection. Canal work, lining, and tailings dams and mining, stilling ponds, and of course landfill, dam protection, and tunnel lining. And finally, green roofs, some work that's going on where you can get soil to stand on the side of slopes using geosynthetic techniques, and now also blue roof technology, which you may or may not know about, which I can't describe now, but it's about the SUDS programs of retaining and holding water back on any surface available, and that uses geosynthetics too. So why just some kind of visual impact on what the difference is? What's the equivalency? Well, there's an old fellow like me holding up a roll of geocomposite, which is equal to 30 tons of drainage gravel. I think that gives you some idea of why it might be easier to place a geosynthetic than it would stone, especially if you have to put it vertically at the back of a wall. And then, of course, when you start to talk about the capacity, the efficiency of a geosynthetic and what it can save, here's an example of a geosynthetic being used to reduce the amount of roadstone needed to meet the standards of a highway. and you can talk about between a third and a half of the roadstone construction depth being saved. Now, in terms of what that saves, in equivalency of trucks, one truck of, say, a geogrid being delivered to site would equal 200 trucks and all the damage that they do of roadstone. Now, what I thought I would do as a retrospective over the 40 years, it's really to think about how engineers, especially geosynthetics engineers, have thought about and been impacted by the environment. And it's interesting having talked, and I'm only going to be sharing ideas and thoughts from IGS members who I've asked, because there's all sorts of illustrations. And these are the recollections of IGS members, including my Australian colleagues. And I go back to my first days in geosynthetics. I wasn't there in the 1950s, but these are the stories I was told when I first got, and I worked for a Dutch company at the time. And one of the earliest events that sort of used geosynthetics was caused by what was in those days just considered as an environmental disaster, not really thinking about why, but then the sea levels there was big storms, etc. And there were some major floods in 1953, which was an environmental disaster, especially for the Netherlands, where virtually 2/3 of the country was under water and hundreds of people died as a result. Now, one of the solutions at the time was the good old Hessian sandbags. They even used boats to try and cover the breaches and stem the flow. But what they also did was develop 8-ton polypropylene geobags, and which were dumped in the breaches in the dikes. And that's where they really started to get going. There's all sorts of people who'll tell you they invented geosynthetics, but that's the Dutch version. That then went on to a major decision by the Dutch government to never let this happen again. And they came up with a massive project called the Delta Works. And then if you're ever in Holland, it's worth going to the museum there to see it. But these are cathedral-like constructions which were in a dry dock, floated into position, and they were on skirts of very high-strength wovens around the base for erosion control, and they put down large multi-layer filter scour aprons, which had multiple layers of geosynthetics within them. That's one of the earlier uses of geosynthetics. Now, in terms of awareness of sustainability, as opposed to dealing with environmental disasters, there was a sort of kernel just starting. There were some mixed messages in the 1960s, and there were some people starting to think about carbon, and there were some of the first graphs being produced from the 1960s on carbon dioxide concentrations, just to see what was happening, and concern going on through the years. And then there was you might see there's some useful advice in Popular Science in the January 1963 magazine on how to get rid of oil when you just cleared the oil out of your engine. So you just dig a hole, put some gravel in, and then cover it up with soil. And that's fine. But when it was really when what's called the Earthrise photo was taken, where astronauts came back with the photo, and people were starting to ponder how fragile our Earth really is. Then throughout the 1970s, there was starting to be some contamination going on, and there was a need to contain water. Population growth was going up to just contain for clean water, but also to deal with dirty water. And the United States Environmental Protection Agency was established in 1970. And I understand that in New Zealand, the Tui mine tailings were abandoned and at the time were considered the most contaminated site at the time in New Zealand. And there were heavy metals and cadmium. And what was starting to happen, they were contaminating the drinking water. And this is in a beautiful area of New Zealand. In 1974, the first double liner under a reservoir was for leak detection was developed, and that was from one of the founders of the IGS, J.P. Giroux, and the reservoir is there in good condition up to this day, and you can see the construction there. And of course, the most notorious project, which was mentioned to me several times by colleagues, was the Love Canal disaster in the US in Niagara Falls. And it was described as a national symbol of a failure to exercise a sense of concern for future generations. So the penny's starting to drop that human beings actually might be causing problems. And of course, the major success story for geosynthetics is the development of the modern landfill. And a large credit goes to George Kerner and his work at GRI, defining the various functions of the various parts of a geosynthetic line system. And I'm sure you know the various components, but it involves the large majority of the types of geosynthetic available: composites and grids, and liners, of course, protection, geotextiles, and the erosion control products. And it is an extremely efficient use. The question's got to be asked is, if there were no geosynthetics, what would our world be like? And my surmise would be that we would be in a complete mess with the increase of population, the waste production. Much as we don't like to talk about landfills, it is still the major place where our planet is kept safe, and that landfill can be used and managed properly and not contaminating the water source. So going on to the 1980s and 1990s, it's a great period of technical innovation. I think the penny had dropped, and in 1980, the control of pollution special waste regulations in the UK was set up. Catalytic converters for car emissions were introduced, and geogrids were defined and introduced. And of course, 1983 was when the IGS was established. And there was a lot of work going on, and it was needed to be pulled together. And in 1985, the ozone layer depletion there was lots of stuff in the news, I'm sure you'll recall, and talk about CFCs and the danger to the ozone layer and the hole in the ozone layer and UV radiation. 1986, geosynthetic clay liners were developed, and in the UK there was some tests done on grass spillways, and this was an idea which recognised, and I kept this in for something which was which is where we started to think of the surface of the earth and organic growth as something not to be stripped away and filled with concrete. The idea that grass could be a structural material, and it was tested to its limit. And the way that was done was reinforcing it with, or stabilizing it with geosynthetics and seeing where the limits are. And that then went on to help design for dam spillways, etc. In 1987, in the Fruit Growers Chemical Company, there was a closure again in New Zealand, and they'd been tidying up the Tui mine, and this took top pole in the most toxic site in New Zealand at the time. And there was 20 tons of pesticides left in the soil. So that rose the awareness in New Zealand, particularly on it was a disaster, again, a lovely part of New Zealand. In 1990, the first intergovernmental panel on climate change was established, and the United Nations in 1992 conference in Rio, which set the climate change framework. And in Japan, the high-speed rail geosynthetic reinforced soils stood up to earthquakes, so geosynthetics were being tested to their limits. And it's the standard way of building retaining walls now in Japan, is using grid reinforced retaining walls. In 1999, the European Landfill Directive and this concept of the polluter pays meant that there was high technical requirement. And so there was a large tidying up of the legislation in Europe, certainly. Other influences like the film Erin Brockovich. Again, I don't know in Australia whether that hit, but certainly in the UK and around Julia Roberts, getting the idea that the ordinary person is being affected by industry, and there was cover up, and this is the need for proper legislation. In geosynthetics, we're developing or just starting to try out electrical and optical detection in geosynthetics. Kasia may say something about that a bit later. European Groundwater Directive came in, and the film The Inconvenient Truth by Al Gore to start to talk about really looking at what carbon depletion meant for the Earth. In 2007, proper design methods for use of geosynthetics in coastal defence in the Rock Manual were developed, and geotextile tubes, these big bags, which were then used mixing chemicals to form flocculants to make contaminated silty materials into a clay, which could then be safely removed or contained. In 2008, there was a third-party auditing to ensure quality on design and construction in Cranbourne landfill, Victoria, and the Victoria authorities started putting high-quality demands on the way that landfills are built. In 2009, Bath University in the UK published a whole series of carbon values for all types of carbon construction materials, and it's the figures that we use to calculate benefits. Then in 2009, there was an introduction of best practice environmental management, BPEM, which a good number of you will know developed in Victoria, Australia. Now in UK, there were standards being set on targets for the UK construction industry, and no doubt in Australia and New Zealand there are similar. But this was what was which was proposed back in 2013, that by next year, as it turns out, they wanted lower costs, faster delivery, lower emissions. So they've actually said this is a target we want, and improved export, as you might imagine. And the construction industry was trying to tidy itself up in terms of safety. And I've heard standards of improving site safety statistics by 25%. And of course, it's the lower emissions that was the target. In the 2010s, this is really where the dawn of sustainability recognition, I believe, happened. In the UK, there was a RAP report looking at how geosynthetics could actually start to save on carbon. This was a government report, and geosynthetics was starting to be recognised. At the Eurogeo 5 Valencia conference, the idea of putting out a sustainability video, which Euro led, and there were 7 papers that were actually published on carbon saving, which was commissioned by the European Association of Geosynthetics Manufacturers. And the IGS produced a video in 2014. The US Senate adopted an amended Water Resource Reform and Development Act, and it actually recommended the use of geosynthetics. In 2015, 196 countries adopted the Paris Agreement and had actually started setting targets. And then in the SUDS manual that I mentioned, the idea of containing water and preventing flooding using attenuation, which uses and identified geosynthetic solutions as an idea. The UN set 17 sustainability development goals, which Neil Dixon and Dr. Tooze, and especially I thought it was an excellent keynote speech, Healing the Earth in Seoul, that Dr. Tooze gave. And she cited how the geosynthetics mapped to the UN sustainability goals. In 2019, again, another thing that that rose the profile in Australasia was the storm washout of the Fox River landfill, and 135 tons of rubbish came down to a beautiful area, and caused a national outcry. In 2019, the IGS Sustainability Task Force was set up. Kasia mentioned that. And then finally, the 2020 IGS Sustainability Committee was formed. So that gave you a sort of retrospective, as I see it, as what's been going on while I've been in this world of geosynthetics. And now I'm handing on to the next generation. So over to Kasia.
Yes, I'm here. And hopefully you can see my screen now.
Yes, Kasia.
Yep.
Okay, fantastic. Hello, everyone, and thank you for this opportunity to present to Aussie and Kiwi IGS chapter. I'm very honored for this invitation. I myself spent 4 years living in Auckland, New Zealand. These days I'm on the other side of the planet. Well, I do not claim to understand fully the business, the projects that you and the constraints you're operating within. However, I'm married to a Kiwi, so your region is very close to my heart, definitely. So whilst David has set the scene and spoke of the past, the progress of legislation, policies, important events or accidents that directed further development relating to environmental engineering, engineered environment. I will speak more about broader present and foreseeable, a little bit about the foreseeable future. And why will I talk about it? Well, in our daily routines, we chase yet another project, another pipeline, deliverables, designs, sales. And it's easy to lose track of the big picture. And I think that the aim of our presentation is just to take a little bit of a step back, look at that whole history and development, and consider what is actually important and where we are all going as well. So I will start this presentation with a little bit of the news from recent months, and that is actually as well quite close to your region. So as this presentation was first delivered in October 2023, this is the news that we have seen here just in September 2023. So that's 6 months ago. Antarctic sea ice reached its lowest maximum extent on record on September the 10th. This is the cover should have been growing at much faster pace during that darkest and coldest months for you guys. So this is contributing to actually a long-term downward trend to human-caused global warming. So that was 6 months ago. Interestingly, this is the recent news. So I'm a subscriber of the UK magazine, and this is what we read only 3 weeks ago. So the Antarctic continent that covers 20% of the southern hemisphere and lies, as you all know, fairly close to your location, is well, it's getting more and more attention from scientists, from researchers from this part of the world as well, and it's getting some publications in just daily magazines or weekly magazines. So this is just to show that the climate action urgency exists. It is here to stay with us for a foreseeable future. In the UK and Europe, we are very much engaged with geosynthetics and their sustainable development. One of the reasons perhaps is due to climate-related research that is produced here. We definitely, the North Pole was getting much more attention than Antarctic up until these days. That's what you can actually learn from those articles is that these days Antarctica is getting much more attention from the climate researchers as well. And this is as well showing that, well, nobody is hiding from that. We are all affected, no matter on which hemisphere you live in. Just one more topic that is, well, probably there is a few topics that are not that optimistic during that presentation, but it's gonna get better. It's gonna get more optimistic further on. So I just wanted to stop here and speak about the planetary boundaries. So back in 2009, over 20 scientists from all over the world, from Australia as well, they came together and created a fairly logical and simple model of tracing emergencies relating to pressure destabilizing the planet. And they as well traced transgressions of boundaries that in consequence are threatening the humanity and the planet. And you can see that being mapped out in the slide. They developed the 9 main categories and quantified the impact of those elements onto the safety of the Earth. So you can see that round green circle that indicates whether the element is within the safe zones, or when it's transgressing, it shows you that we are getting into well, dangerous and uncontrolled really zones, and we're not too sure how, the scientists are not too sure how this is gonna affect the future of the planet. Some of the items were not quantified back in the 2009. So for example, novel entities were not quantified at the time. But you can see that the climate change element that is at the top of the screen has already been in 2009 on the growth, on the rise, unfortunately. Then more recently, in 2023, in September, all of the 9 boundaries were actually quantified and mapped out. And yes, and showed that the publications from the 2023 showed that already 6 boundaries are transgressed, which indicates quite difficult to predict influence on the future development of and the future safety of the humanity. Novel entities, as I mentioned before, are the items such the new products developed. Actually, microplastics sit within this region as well. New chemicals being developed, and these are just yes, going quite high up. So, where are we now? It's April 2024. We are, well, nearly 10 years, to be fair, after the Paris Agreement, which seems quite crazy, to be fair. This presentation was delivered just ahead of the conference of the parties in Dubai, but these days we are just after it, and we are ahead of the COP29 in Azerbaijan. The first global stocktake report was published as well, just ahead of the COP28, and that report was published just in September 2023, and it presented 17 key findings. The stocktake report was scheduled in Paris to be published every 5 years, but it took them a little bit longer to review just thousands and thousands of the different documents that were produced by different regions and different countries. So the stocktake report aimed at reviewing how the nations are progressing towards decreasing the rise of the Earth temperature, towards limiting the greenhouse gases emissions. And I will take a very quick look at that report. We're not gonna go through the 17 findings of it, just a couple of quotes from it. So it's probably not a surprise to you to read that quote from the report, that the world is not on track to meet the long-term goals of the Paris Agreement. And the second quote, well, rigorous accounting and accountability are needed. In many countries, the issue is around probably top-down communication. Regulations, leaders of organizations, large organizations, public organizations, they do endorse greenhouse gases technological solutions to improve the situation. However, what we observe here with David, we've had a few discussions actually as we were preparing for the presentations about it, and we both seem to observe similar problems, that once the high-level decisions and endorsements exist there, they don't yet trickle down to the people on the ground, the whole face, if you like. There is still a bit of the disparity there. I think it's still a work in progress. It's getting better, but there is still, yes, not enough focus with the project decision makers on those, on the trying. There's not much focus from the project decision makers trying to make that actual change, to implement new alternative solutions that will cost you less carbon emissions. Definitely a lot of good work is happening, but as I mentioned, still work in progress and a lot ahead of us. And a few numbers and the table for you here, as there is probably many engineers among us on the call, and the engineers look a good chart. So here's a very recent, again, publication, just the last year. And that one shows you countries and regions and how they are progressing towards the climate change mitigation. What is their journey? So we can see, for example, here how the CO2 emissions, what's the percentage from the given region, and how they are, whether they are tackled by the net zero targets policies, or whether there are any other mitigation targets. These are marked in blue. However, they get no targets at all. So the green one represents the percentage of the net zero targets for the production of the for greenhouse gases emissions. So there is no specific bar for Australia and New Zealand. Australia and New Zealand is hidden under the others, with probably roughly 20 other countries, which are still the major contributors. And Australia was actually the first one on the list, followed by Brazil, Malaysia, Indonesia. Poland was there as well. So we can see that there is considerable amount of effort given to the reduction of the CO2 emissions. There are rigid targets set up. Different stories whether they are followed through completely, whether this is actually in practice happening. But that's the good start. We've got as well other mitigation targets, and there is still a considerable amount of the emissions that are not targeted at all. And probably the others, so these would be the countries of the Asia as well. They are they've got still the highest unmarked, no targets attached to the emissions. One more interesting thing here is that the total emissions are at 36, marked here, are at 36.7 gigatons, which translates into, well, nearly 37 billion tons, actually, depending which units you prefer, which is a hell lot of the emissions, actually, that we are producing. And yes, and that's annually. So let's move closer to our industry, the construction industry. And so the quantification from the United Nations Environment Program is that 40% of this 37 billion tons, I just quite like using billion tons opposed to giga, but nearly 40% of this production is associated with the construction industry, which is well, quite a high, well, it's a ridiculously high number. However, when you think about how much geosynthetics actually can contribute to lowering the number, I think that the things are getting more and more positive. And we are lucky enough to work for the industry that can seriously affect that number. When we consider how much aggregate, concrete, maybe sometimes bricks or even steel, the MSE walls we can save, the geosynthetics, they tell definitely a fantastic and very green carbon footprint reduction story. So I think that we are very much lucky and in the right, ethically even industry to be working in. And let's switch now to the IGS Sustainability Committee and how we are trying to spread that good message that we have, to share the information with people. I'm not going to talk about all the IGS Sustainability Committee activities, just picked here a few ones that stand out more. So we have launched probably good 3 years ago the campaign Did You Know, that meant to attack the social media with information on the geosynthetics, spread the knowledge. But still there is plenty engineers that don't know much about the geosynthetics, that have very little idea. And now working for the manufacturer, I'm just finding daily that, well, people don't distinguish between the products, between the applications. So this constant flow of information is required. And one more reason, one more way of just conveying the message is another initiative that was launched fairly recently, so sustainability case studies. I would like to encourage each and every one of you on the call to go to the website of the IGS and to submit your own case studies where you can share the good work you have done on the project that relates to geosynthetics. What sustainable development goals were attached to the project. The document that you need to fill in is just easily accessible on the website. You just need to fill the form with your information, attach a couple of photos or so, and and contribute to that information sharing and just knowledge share amongst the wider community of engineers. Another very recent initiative that was launched just in September last year in Rome during the ICG was the creation of the sustainability calculator. So IGS partnered with One Click LCA, and with a few researchers as well, academics, that created 9 templates that are available for access for every IGS member to go and compare different applications and to compare traditional and geosynthetic design solutions in terms of the emissions quantity, CO2 emissions. I say traditional design, but I think that David just proved that geosynthetics are just are becoming very much traditional designs as well these days. We've seen them for so many years now, but it's still the language that keeps on lingering around. So the LCA calculator allows you to quantify the solutions, see the savings in the CO2 emissions. There exists a video training on the website, and as well frequently asked questions, all available on the website to help you move through the platform. One-click LCA. I'm aware as well that Boyd Ramsey is just either has already launched or is just about to launch his a little bit more in-depth training on that platform, how to use it, how to operate within those different templates for different applications. One item that I wanted to mention regarding the CO2 calculators is that here in the UK, for example, quite a few public organizations, such National Highways, they operate using their own calculators prepared in an Excel spreadsheet. Geosynthetics do exist within those calculators, but they are not considered in a fairly depth. Network Rail as well has their own carbon calculator, so the different organizations do pay attention to those elements, but as mentioned, still at fairly high level here. Just a little remark here as well, that European Federation of Piling Contractors and the Deep Foundation Institute, they created their carbon calculator, and that's been launched already a good 10, if not more, years ago. It's being constantly updated. That does not include geosynthetics, but it's just basically to show you that different industries in the construction, they actually are paying quite a lot of attention to those calculations for the carbon footprint emissions. It's a fairly standard thing for big consultancy houses that they have their own carbon footprint calculators to quantify emissions on their jobs, as this is becoming a standard requirement on the larger public jobs. And as well, responsible geosynthetic manufacturers also have their own carbon calculators available for the clients, so they can quantify and compare the alternative solutions with geosynthetic solutions. So let's jump into the last part of my presentation, which is what is next? What's out there waiting for us? This is obviously a subjective opinion of myself, but I think that there is quite a strong foundations for those predictions. So we spoke about the carbon footprint calculators. But where the information comes from to estimate the quantities of CO2 emissions? David spoke about RAP report from the 2009. That was definitely the first scientific Bible for those environmental estimations. But these days, IGS Global and IGS Sustainability Committee encourages manufacturers to create their own EPDs for the products, environmental product declarations. Well, through the competent and professional services that go and audit your organization, they come and prepare the full-on quantifications of emissions at every stage of the production. Cradle to gate is probably by far the most common currently available EPDs, but many manufacturers are working on the extending the content of those EPDs. From the recent survey, from the recent conversation, I think that in Australia, these EPDs are still not that popular document, but I think that this is what you're gonna see arriving more and more frequently as the government and your state government start start adopting the your net zero targets and quantifications requirements on the project. Those EPDs, they can extend from they can address all the life cycle assessment, but at the moment it's for the geosynthetics, as I mentioned, it's cradle to gate, maybe a little bit more when the material goes out the gate, the estimation is quite often very much project specific. EPDs can as well help you to prepare your environmental statements, showing and quantify your net zero targets and present your climate action plans. We are as well observing in my company that there is more and more requests in Asia actually about the EPDs. So this is slowly coming. It's very much embedded at the moment in the UK and many countries of the Europe. You actually cannot sell your products in some countries in the Europe without this document. So this is here, and this is approaching elsewhere as well. Another topic that I think is going to be more and more frequent in the future is the use of the recycled content in the manufacturing process. Well, that's some of the manufacturer has been using that for years already. Manufacturers in South Africa, you've got in Australia manufacturers as well that use the recycled plastic bottles in the manufacturing process. But there are still some issues potentially related with the energy, how heavy on the energy it is to recycle actually the bottles. It's still maybe not as efficient as you wish, but going forward, I think it is a step in a good direction, using the already produced plastics to produce the new geosynthetic materials. We're going to just see more efficiencies happening within the production process, I believe. And yet, what is another thing? Use of biodegradable geosynthetics. Yet again, it is a type of the product that has been with us for years. They are in wide use in many applications where they are suitable for erosion control or supporting seed growth, glacier protection. But seeing some recent publications, and yes, I believe that there is still a lot of development happening in the academia to try to find new products, better products, stronger products for those applications. Well, depending on the application as well. So I think we're going to see more of those products in wider or in more applications in the future. So this is going to be interesting development as well coming forward. In terms of the monitoring systems as well, I think there's a lot of attention that geosynthetics are getting. One is a monitoring of the existing and performance of the geosynthetics, but also as a carrier of the instrumentation to help monitor the actual structure. There's been many who have tried and many who are working on it. So I think we're going to see some good and hopefully commercialized products in the near future too. And the very last slide from me, seeing we're running out of time. And the very recent from the last year news, I think it was a fantastic development as well, when one of the manufacturers managed to achieve the full circular economy with the production, installation, distribution, installation, retrievement of the geosynthetic material from the site, having it fully recycled, fully cleaned and applied at the beginning of the production line. I think that we're gonna see as well more manufacturers paying attention to that type of the products where we're on the project where the geogrid has to be removed, and it's probably the minority of the projects, to be fair, 1-2%. But I think we're gonna see as well a little bit more development within that area. And it's back to you, David, for the last minute or two. You are on mute.
Thanks, Kasia. Thank you very much. Excellent. I just this is if you like a more personal comment, and I want to do this last slide as a sort of challenge. Here am I near the end of my career in geosynthetics. I'm handing on to Kasia as the sort of image I've got in my mind. And for years we've been saving the Earth, and I've got a series of examples of calculations that have been done and looking at not only cost saving, but carbon saving. And if you look at those figures, I won't go through in detail, but 57% versus 55% in cost saving, carbon saving, 55, 50, 64, 48. For back of wall drainage, 94% saving carbon and 55% saving cost. Now, the message I've got is that really, geosynthetics reduce carbon between 30 and 90%. Geosynthetics reduce cost 30 to 60% in cost. So no one can complain it's going to cost more to save the planet. Now, it gets me, I must admit, it gets me angry when, Kasia said that things, she said very gently that people are taking time to move. And I think, how do we get this message over? It's not like it's an idea anymore. We've now quantified these things. And I know there's a lot of greenwashing goes on, but these are carefully calculated things. This is what the IGS is about, to regulate what's being said. And I think we've acted extremely responsibly over an extremely long time. And we've been saving the Earth. These benefits have been there, even if we haven't quantified them, for 40 years. And I think it needs the IGS to be less diffident. We've got a fantastic message. It's simple and it's extremely important based on what Kasia has just said about what's going on in the planet. And I think we have a moral obligation. We've been given this gift of information, and we have a moral precedent to go out there, and if you need to, beat them around the head, the government people who aren't moving, to say this is wrong. And I think we need to be more aggressive in our message. So I absolutely endorse what Kasia has been saying. I'd like to back up, and thanks to all my colleagues in the IGS for the, if you like, their back history. And I think I'd like to just stir you up, as it were, to go and say, this must happen. Thank you very much.
Thanks a lot, David and Kasia. I think that's a very, very important message towards the end of the webinar, and that's exactly the message that we should be sending towards all the people, designers, contractors, authorities, and countries. So I'll open the floor for maybe one or two questions if there are any questions from the attendees. I mean, it's a fantastic webinar, and I think we should do more this kind of webinars to a bigger crowd.
I think just a comment from me, and we've just recently run our second Educate the Educator series here, and I think that's another key focus area for ASICs and for the RGS as well, is getting geosynthetics into the undergrad curriculums at universities, because a lot of graduates come out not even knowing the difference between a geotextile and a geomembrane. So getting that built into the curriculum so that when engineers come out into the workforce, they're aware of these products and what benefits they offer, will also hopefully lead to them getting used more. So that's the one area of attack, but the other is definitely getting government officials and governments to move on using well-tried and trusted traditional designs, and getting them to acknowledge that there are sometimes better ways of doing things, and that's a bit more of a difficult process.
I think if I can comment, it's not neutral, this thing, because there are strong political powers around. For instance, the concrete industry is very well represented. And in the Institution of Civil Engineers that I'm a member of, I see on a regular basis adverts made about how green the concrete is. Green used to mean bad concrete, but now it's being said, look, the new idea will make it less damaging. It's one of the most damaging materials on the earth. And one of the best ways of saving against concrete, the damage concrete does, is to not use it. Now, there's a strong lobby saying, look, we can't have this. But with a lot of geosynthetic solutions, you can get rid of the concrete. And that's a political message, but it has a massive saving.
We have questions here that says that can we have an access to the slides?
From my point of view, I'm happy with that.
Yeah,
Maybe a
no
PDF
problem.
version, yeah, that would probably work. Right, I don't want to take too much of your time. I mean, it's a bit. I think it's a bit late in Australia and New Zealand. It's probably dinner time soon. And thanks a lot, David and Kasia, for coming up. I mean, so early in the UK. And hopefully, you enjoy the webinar. And I'll see you guys next time in the next webinar. Yep.
Thanks all.
Thank you all.
You.
Thank you.
See you. Bye.